Hi, welcome to your lesson on stem and leaf plots. Stem and leaf plots are a simple but very effective way of representing data in statistics. For the first part of this video, just watch and listen and learn, and do not worry about taking notes until the very end. Alright, so here is an example of a stem and leaf plot. Notice there's a stem here, these single numbers, and leaves. And stems will always have one number, whereas leaves can have more than one. You can see there's many numbers in each leaf here. This data represents baseball throwing distances in feet. A stem and leaf plot should always include a key. In this key, we see a 3, line 2. That means a stem of 3 and a leaf of 2 represents 3.2 feet. So now if you look at our data, for example, the shortest baseball thrown here was 2.0 feet. The longest one was 10.5 feet. And in the middle here, we have all kinds of other distances of baseballs thrown. For example, 5.0 feet, 5.3 feet, 5.6 feet, 5.7, 5.8, and so on. All right, so again, main thing to note is these leaves, each of them represents one separate piece of data, and you use that number in front of each of those. All right, let's look at another example. So here's another stem and leaf plot. This stem and leaf plot below shows the masses in kilograms of some people in a lift. A lift is a fancy British way of saying elevator. All right, so these are the masses or weights of people in an elevator. Two questions. Number one, how many people were weighed? So if you look at this, how many people were weighed? Again, we need a key. Let's take a look. The key here is 2, line 4. So stem is 2, leaf is 4. That represents 24 kilograms. So if we look at our very first piece of data, 3, line 1, 31 kilograms is actually the person who weighs the least in the elevator. If we go all the way to the bottom here, there's some people that weigh 80 kilograms. Here's 81 kilogram person. Here's an 86 kilogram person. So how many people were in the elevator? All we have to do is look at the leaves, and each of those represents one piece of data. Again, 31, 34, 43, 43. So how many people is this? Hopefully you answered 16. If you count the leaves, that's 16 pieces of data, 16 people. Second question. Range, here's how we find it. 86 minus 31 equals 55. So again, highest minus lowest gives us the range. So the spread of weights in the elevator is 55 kilograms. All right, so try the same thing for this piece of data, this stem and leaf plot. This one says it represents long jump data for a group of students. So here are distances students have jumped, but we don't know. We don't have a key yet. Is this 23 feet, 23 meters, 2.3 feet, 23 inches, 23 centimeters? How long did these students jump? We need a key. All right, here's our key. 3 is a stem, 5 is a leaf, represents 3.5 meters. So the shortest jump right here, 2.3. Longest jump, 5.0. So answer the two questions. How many jumps were recorded? So what's your answer? Hopefully you had 10. We can see again the leaves. You count the leaves, and the leaves tell us how many pieces of data we have, and there's 10 of them here. 10 jumps. Second question, what is the range of data? What's the range here? Take the biggest one, 5.0 meters, minus the smallest one, 2.3 meters, and we have our range, 2.7 meters. Great, here's some data. What is it though? All right, it is math test scores. And often the first step with data is to take it and reorder it from lowest to highest. Notice this is all scrambled up. That's how you might collect data, but when it's time to analyze the data, it's good to put in order. Lowest, moving up to highest. All right, once you have lowest to highest, making a stem and leaf plot is easy. Numbers, right? Here's the 50s, the 40s, 30s, 20s, 10s, and then this represents the numbers under 10, which we have two of them right here. Right, so our first leaf is going to be 0, 3. 0, 3 means 3. And the next leaf is going to be 5, because 0, 5 means 5. Then we're in the tens, so we're going to jump to here in the tens, and our first one is going to be 3 because we have 13. So here's 13. Next one, 14. Then we have 14 again. So what do? Do we put it here or do we skip it because we already have 14? Well, the answer is put it there. We need to represent every piece of data here. So 14 is 2 separate pieces of data. We need 14 to appear twice. Then 18, then 19. All right, now follow along and see if it makes sense. We have 20. There's 28, again, 29. Now we're in the 30s. Now we're in the 40s. And finally, the 50s. 50, 56, 58. There's all our data. There's a good looking stem and leaf plot. Gives us an idea of how the data is spread out. We can see there's a lot of data in the middle, few in the high, few in the low. It really gives you an idea of what the data looks like. All right, and there's a key, of course. Time to take notes. So you're going to do one on your own now as your notes for this topic. Please write a title, stem and leaf plots, and try this one. So we have some data here. Your job is to take that data, create a stem and leaf plot, which has the following key. 1, 9 represents 19. And then answer these two questions. What is the value of the last stem? And list the leaf values for the stem that has the most leaves. So imagine you have the stem and leaf plot here, you have the stem. This question says, what is the last stem? So if you look at all the stem values, what's that last number? And here, look at all the leaves, where are the most leaves, and list those leaves for the stem that has the most leaves. All right, so hopefully your answers you got were those, and those answers can be seen clearly if you drew the stem and leaf plot properly. For example, what is the value of the last stem? Here's our 19, here's our 20s, our 30s, 40s from this data. 50s, I guess there's no 70s, 80s, or 90s, but there is a 105 right here. So that's your 105. So the last stem is 10 right here. And then the leaf values for the stem that has the most leaves. Look at these stems. Which one has the most? Turns out that the stem 3, in other words, the 30s has the most leaves. That means there's the most values in the 30s here. And that's true. We have a 31, 33, 35, 36. And there's those values. There's the leaf values. Great. If you got those right, you have a good understanding. And we will see you later.